Hello and welcome back to a new video in my GameEngine video series. In the last video we have implemented a window. Yay, there it is, we have a window. It's nice, it's cool. And yeah, today we want to pick up the window and we want to actually integrate this one with DirectX. I'm not really sure how I want to do my DirectX implementation. I think since DirectX is completely Windows independent, I think that I will add it to Windows. I do not want to have a own project for that, but if we would add Vulkan or OpenGL at some point, which we need to do if we want to make it compatible with Linux, we would need to do either OpenGL or Vulkan, which I will probably do OpenGL because we're going to start with a 2D engine. But then we would have an own project for that. Okay, so let's make just a folder, D3D12, inside of Engine Windows. And then we can do all of our DirectX magic in here. But before we do DirectX magic, we of course need an interface for that. Why would we not need it? So we're going to have an iGraphics interface. And this is an interface that's implementing all the interactions with graphics API directly. So I ask iGraphics, public, virtual, okay, not Java here, virtual, iGraphics, default, come on, like that. And then what I want to do is I just want to have a bit of an informational API. So what I want to have is I want to have a const char pointer. Do I want to have it as a const char pointer? I'm not sure. Why do we not use our fancy string view? No, I think string view is more a thing that you use as a functional argument, right? So that you can accept multiple, but these are probably, but are these going to be const chars? Yeah, I mean, yeah, let's just make them const chars to make it more easy. Get API name, that's a very simple API function that we're going to have. Virtual, of course, which I tend to forget. Get API name, get GPU name. These are the two functions that I want to query so that you can get a bit of insights on what's going on. Just the API name and GPU name. Very, very simple. So defines interface to the core graphics API. So in the end, we're going to have a bit of a segregation between graphics and the actual rendering. So graphics will be the raw DirectX graphics objects. Like the swap chain will be handled in the graphics. Begin frame, end frame, things like that will be handled in the graphics. So the really core interaction with the graphic API and the window on the graphics. Then what we're going to have later on is a layer stack management system, so that you can have multiple layers that the application is composed out of it. We're going to start with probably some 2D layer and some ImGui layer and maybe a debug draw layer in between, so that you can have some debug drawings, and ImGui probably we would remove that in production, and it's only then going to be there at development. But I do not want to exclude it directly because maybe you still want to have a bit of ImGui even through you are in production. And this one is going to be the raw interface. It will not have anything to do with actual rendering. I mean, yes, it will have a bit of something to do. We're going to have a begin frame, end frame, and present method exposed, or maybe I think end frame is probably going to present directly. Yeah, so that we have a bit of interaction going on there. But for now, it's these simple APIs. So the informational API returns ASCII string. Okay, so this is going to retrieve the name of the underlying rendering API, retrieves the name of the GPU handling the drawing. Okay, and that's basically everything. Okay, so this is a very simple API. So now let's make the D3D12 graphics.h. Namespace engine class D3D12. I copied it already, nice. Let's include the engine core / iGraphics.h, which I mistyped. iGraphics, there we go. And then engine Windows win include.h, that's everything that we need. And what we would also need is then our nice little com pointer that we require on Windows, com pointer.h. Problem is com pointer is not known yet, so let's find out our com pointer. Let's go to gist, blah, 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 blah. There is my com pointer, and let's grab my com pointer like that, and here we go. There we have the com pointer. I hope this is the most up-to-date and good version. I don't think what is that, unlicensed. Ah, I was really nice with that one. No, but that's like a com pointer. You don't really need to care about licensing with such a simple thing. Com pointer is something for me that is belonging to Windows and should be in Windows in the way that I have programmed it. Of course, everybody says it about their own code. I don't really like the com pointer shipped with Windows actually, but yeah. Okay, so that's everything that we need for now. So basically this implements D3D12 drawing. Okay, simply like that. I need a string for my GPU name because I need to store it. And then we have a public. We're going to have a constructor and a destructor. And a destructor, and then we're going to have some private members in here, which is especially for now the GPU name, because we need to get access to this one, which is a public graphics. And let's go in and implement a virtual methods. Let's press OK. Yeah, sure, you need to do it in the header because I don't have any file for it. I can actually mark both of them. Sadly not. I really like the jumping there actually. Okay, so now I have these in here. I don't like that Visual Assist is thinking to know better how to format my code. And Visual Studio as well. I'm always a bit on a fight with these, because I like my structure to look a bit different. Okay, so let's create the implementation here, and let's create the implementation here. Okay, now the first thing that I need to do is I need to also add some debugging. So I want to have this in their own class, D3D12 debug.h. I'm not sure if this is a good name, actually, because like this, I'm not sure if there's a header from Microsoft. Let's just go for it. Namespace. Yeah, I think maybe we are good. Engine class D3D12 debug. That's something that I need to do, and there's a very, very important thing for this debug class. Basically, this debug class needs to be conditionally compiled only on debug builds. So let's include engine windows win include, and what I want to have is I want to have a bake macro if def engine debug. I think no, we called it conf debug, if conf debug, else, and if. Or maybe, don't want to know. No, maybe let's leave the class intact and just do this for the implementation and the members, right? Would be not so cool if there is if there's stuff happening, because we're going to have debug interfaces. Let's maybe have it if def conf debug in here. And then let's add some com pointers. We don't have debugging DirectX yet. Debugging DirectX we need to include, so hashtag ifdef conf debug, hashtag andif, hashtag include D3D12 SDK layers, and what we want to have is dxgi debug.h. These are my two headers that I need only on debugging, and then I can say id3d12 debug, d3d12 debug, this is the interface that I need, and an I dxgi debug1, And I think we're really not going to use the DXGI debug for now, but I still want to have it in there. Okay, so basically what this class is going to be, it's just going to be in existence. Or maybe we're not even going to do it like that. Void enable debug and void disable debug. That's the two functions that I want to have. And basically these shall completely not do anything if we are not debugging. We are not debugging. They basically should just have an empty function body. That's everything. I think this is the simplest way to do it. Now ending debugging is quite simple actually. D3D12 debug.release DXGI debug.release. The only thing that we might want to be concerned about is the report lifetime objects. And I think we should do it in between here. So I think this one is something that we can only do with DXGI, so it's good that we have it. DXGI debug, and I want to say report live device objects, which is going to be a bit hard. Ignore internal is what we want to have, and we want to have detail. And this is something that I do not really understand, that it doesn't work out of the box. DXGI debug RLDO flags, DXGI debug RLO flags. You need to cast this manually. Don't ask me why, but you need to do it. And this is how it works. The other things is the GeoIDs, the app ID. For that one, it's also a bit hard because it's not like properly documented. IDXGI debug, and please the English version, DXGI debug GeoIDs. DXGI debug app, we just go for the all to get information about all of the objects, and we should be good. This is really important so that you can see if there's any objects still dangling, but this code shall no longer be compiling. Okay, that's interesting. But I don't care about that one currently. Why the hell? I think it's more of a general problem. That's interesting that we get such common, such interesting bugs, but let's just first finish it up because I think we have a more general problem. Let's first get all these interfaces. So DXGI get debug interface 1, 0, because this is not used. Okay, we're going inside of these, and what I want to have is the DXGI debug like this. DXGI get not D3D12 get debug interface, and I want to get the D3D12 debug interface like this, and then as soon as I retrieve both of these debugging interfaces, the D3D12 debug interface is going to enable the debug layer. This is basically how it works. So we have two parts to DirectX 12, DXGI and D3D12. DXGI is the DirectX graphics infrastructure. It's used by DirectX 11 and DirectX 12, and it's D3D12, which is the actual rendering API. The DXGI interface is used for things like interacting with the display, implementing the swap chain, and things like that. I think you can even go and completely implement the swap chain on your own without using an existing one. I'm not sure if it really works in the end, but there's a way to like claim the monitor and claim it to a buffer, and there are like a lot of things that could work in DXGI, but this is like all infrastructure stuff that you should not really care too much about. The only thing that you can care about with that is that it kinda is the base class of DirectX 12. Kinda. I do not really know how it works, because for you, DXGI is only exposing itself as being the API to draw on the screen. However, you can use the DXGI debug to report live device objects, and you're going to catch DirectX 12 objects, which you can also see by the class here, right? D3D11. There should be also a D3D12. What? Interesting. It's interesting that it does not. This should be in Direct. It should be also for DirectX 12. Or did they get rid of it? Yeah, you know, there's also one for DirectX 12. Okay. Yeah, you can see like there's a bit of magic going on here, but this is the way I would always recommend doing it. This looks quite simple, but believe me, that was too easy to come up with exactly this. Because normally what you could just also do is you could call this exact same function without this stuff, or with that stuff, but a bit different. You could also call it on a DirectX only object, but with DXGI you're going to get the advantage that you do not get by default always one object that seems to be still living even through it's allowed to live. This is, for me, the proper way of doing it. Maybe there's still an issue in there, could be, but yeah. Let's integrate that one. D3D12, and I do not know why you don't want to autocomplete today. D3D12 debug.h. Okay, there we go. Now what I want to have is I want to always have a D3D12 debug instance in here. And the thing is, since the debug instance is abstracting away all of the madness of handling that, it's super simple. Now first let me maybe implement these ones quickly. D3D12. Okay, like that. API name simple, GPU name, don't care about that one yet. And in here, mdebug, enable debug, mdebug, disable debug. It's as simple as that. That's the only thing that we really need. And we have debug. Let's see if this one works somehow. I have a bit of a problem with the comp pointer. I'm not sure about that actually. Why the hell? Why the hell is this not working? Huh. That's really interesting. That's really funny. That's really odd. Normally it's the first issue that fools you. It's just a type trait. Why the hell? Why do I have multiple comp pointers? Should not be the thing, right? Ah, lol, I pasted in twice? Okay, yeah, sure. That's not how you should do it. One time is enough. Layer 7 problem. No, layer 8. I don't. Fuck, damn. Sorry. Okay. This is now working again, but now we of course need to integrate it. First of all, engine context is going to have an I graphics.h. There we go. And we will have an I graphics in here, GFX. I do just want to call this one GFX because graphics. Yeah, or do we write it completely? I mean, it would be. I think it's a bit more plain if we write really graphics. This is, I think, something that we should do. Yeah. So now we just need to initialize this graphics object, which is again going to be part of the Windows engine. So we're gonna go into D3D12. D3D12 graphics.h. And what I'm going to do is I'm going to fill in the graphics. Now it's important, first the window, then the graphics, because the graphics need the window to work on. You're going to see how that is later. And now we should have D3D12 graphics and a lot of problems. Why do we have a lot of problems? Because we have missing symbols. And how do we get these missing symbols? We're going to go to our empty game. We're going to go to the linker. We're going to go to the import, all configurations, D3D12.lib and dxgi.lib. That's what we need. I think we will actually need more, but let's just hope that our problems being solved with that. No, but the problem is that there is dxgi debug all. That's the only thing that currently fools us. And this is something that always is a bit of a pain to figure out. I do just hope that I have done it in the proper way in the DirectX 12 YouTube series. There should be the VCX project. And there should be somewhere, should be a definition of something called dxguid. I think it's that one. That's something that people are a bit fooled sometimes, and it's not really documented that you need this library, but this one should define all the DirectX related GUIDs. Yeah, exactly. And now you can see that we are up and running. You can actually even see, if you take a look at the D3D12 SDK layers.dll is loaded, D3D12 core, dxgi debug has been loaded, and maybe even the core DirectX one, DirectX12.dll, dxgi.dll. So you can see that we actually are talking to DirectX 12. We are not yet talking to the GPU. There's no driver yet loaded, no driver DLL loaded here, which we need because the driver more or less, that's like another side. Like DirectX 12 has two sides. DirectX 12 has the application side and it has the driver side. So there's actually a driver API of DirectX 12 that the driver needs to implement to support DirectX 12. Not sure. Can we actually find that? Driver API. Is there something? No. No, I'm not sure. There should be a driver API at some point where I saw it once. I'm not sure about that. There should be at some point, there's actually a different side to the API that the driver implements. I'm not even sure if this is open source through. If this is the driver API open source, I don't know. But I don't even care really. Yeah, but now congratulations, we have the debugging libraries of DirectX loaded. Now to get rolling, what we need to do is we need to have something called the dxgi factory. That's something that we need, dxgi factory, because the factory is going to be responsible to retrieve information about the GPU and also to find the GPU that we want. So the first thing that we need to do is find GPU. First maybe let's say maybe init factory, and initializing the factory is not actually even too easy. dxgi create dxgi factory 2 is the function that we want to call. We need some flags. I'm just going to put into 0 quickly, and then we need the actual pointer where we want to initialize it to the factory. And there's another parameter here. So basically there's a dxgi create factory debug flag. That's a really important flag. So let's do an uint factor or dxgi factory flag, and let's put this one to 0, and then let's use the dxgi factory flag in here. And if the conf debug is defined, basically what I'm going to say is that flag is equal to the debug, and then there's an end if, and so you can see how we can create it in a debug way. So now we have the factory, and with that factory we can now actually find the GPU. So let's find the GPU. For the GPU we need to have a com pointer I dxgi adapter. Adapter is kind of like the GPU. GPU adapter, so the actual GPU itself, and we can find that by basically calling a function on the factory, which is called dxgi factory, and it's called enum adapter, but that's not the right enum adapter that I need. I think we need a factory 2 for that. Enum adapters 1, no. Do we need a factory 4? So like more specialized interfaces. enum, no, 4 is even too old. 5, enum adapters, no, 5, 6. Enum adapters by GPU preference. This is the one that I am looking for. We want to have the first adapter for the preference high performance. So we want to have the most high performance GPU. And we want to enumerate that adapter in here. You can see it's called enumerate because it can basically go through. So basically it's going to order them by high performance, and then 0 is the most high performance one, then second, third, fourth, fifth, and so on. And yeah, this is basically used to find the GPU. Then what I want to have in here is I want to get the GPU description, which is a DXGI adapter description. So a DXGI adapter description, GPU description, which is something that we get here. And what I want to do is boom, get a description like that. Now we have the GPU description, and inside of this GPU description, if you take a look at that, there is the description, which is a set of W chars, which I really hate because we need to convert them now. First of all, what I want to do is I want to make sure that my string is actually, I think we can make it for a certain size like that. Is it possible? No, cannot initialize it. Okay, however, what we need to do is we need to convert it. So the GPU name is going to get a reserved buffer size of 128 because this is as many characters as we can potentially have. But we're just going to reserve it inside of the buffer. So the capacity. And what I want to now do is I want to convert multi-byte char to multi-byte is what I want to do. CPUTF-8. Flags. Do we need flags? I'm not sure about that. Let's quickly see the reference to that function. This is basically a string conversion function from Windows. I think we do not need flags. No, we don't need them. So let's put 0 in here for the flags. Then we want to have the white string. The white string is GPU adapter dot no GPU descriptor dot description dot description. So something like that. Then we have the white characters. -1 means figure out the size by yourself. Then we have the multi-byte string where we want to put it into. mgpu name dot data is the buffer that I want to go to. Size is 128. No default char and no use default char because they're not supported. And then we should have the information about the GPU available. We can make a breakpoint and quickly check if this code is working by going in here. Okay, so let's take a look at the this pointer, NVIDIA GeForce RTX 3090, which is exactly what I was expecting, and it's converted to a proper name it's stored, so the code worked. Might have a fool if it closes. No. Disable debug. So let's go into the destructor, because what we also need to do is we need to destroy all objects. The adapter is destroyed itself, but the factory is something that I want to release manually because it's a certain order, right? I want to just keep the order. So now that I found my GPU that I want to use, we now actually need to create the device. So we need to actually create the D3D12 device. So D3D12 create device is the function that I want to call. We have an adapter here. We feed in our GPU adapter. We need to feed in the feature level 12.0. And then we have an output, which is an IRD PPV args pointer. So which device do we need to do? So let's make a comp pointer, ID 3D12 device. This one, GPU device. Okay, and this is then going to go to the GPU device. So now we have the device created. Oh, what? Huh? What? IID PPV args. What? This should work. GPU name? No, GPU device, of course. Like that. Okay. So now we should have a GPU, and if I run that, let's see if what we get. Okay, you can see if I go into this, that the GPU device is actually a valid pointer, and if you take a look at the right, at the output, can actually, let's maybe continue that quickly and close it so that we have a bit of a better view to the output. You can actually see that there's a lot of stuff going on now. You can actually see that loaded file repository NV camera, if we go let up here, NV WGF UMX, NV GPU COM64 DLL, NV LD UMDX DLL, and you can see that this is all in file in system driver storage file repository NV display inf AMD and some number. This is actually the GPU driver. These DLLs come from your video driver. So if you have a different driver, these might be a different path. If you have not an NVIDIA GPU, it's probably not going to be NV disp. So in the end, this is now because I have an NVIDIA GPU, it's loading these NVIDIA drivers. And it's also loading more things. It's, for example, also loading Windows. I saw it somewhere, Windows.storage. Where is it? Not sure about that. Here, Windows storage.dll. So it's also using like DirectX storage and DirectX IL conf.dll, D3DS cache, Direct3D shader cache probably. There's a lot of things going on in the background that is now happening just because we create our device, which is like a cascading loads of DLL towards the driver, because we are now our application wants to actually talk to the GPU, so we need all of the driver code to be available. So all of the kind of like not driver code, like DLLs coming from the driver. We are here completely in user mode. So all of the DLLs related to the driver to talk to the actual GPU, it's all done now since we are creating a device. And what you can also see is we get a warning in here. D3D12 warning, live ID3D12 device add ref count, state creation warning, live device. This is because we are not releasing the device. We are creating the device here, we are releasing the factory, we are disabling debug, and while disabling debug, we are basically reporting live device objects, which means that this all happens before the default constructor happens. And since we're not destroying the device here, we're getting that error, which is indicating that we have a programming issue. And if we solve the programming issue here, if we run it now, continue on, we close the window, we are no longer getting that warning. And this means that our code works as intended. Well, we have a D3D12 device. However, a device is not enough. What we need is a device and we need a queue. So we need to have a queue where we can execute work on the device. We're going to keep it for now simple. I do just want to have a very, very simple queue here. So compointer ID3D12 command queue is what I want to have. Direct queue. Queue like that, and then for the queue we need an auxiliary object, which is a fence, D3D12 fence, direct queue fence, and then what a fence needs is a fence value, so uint64 value equals 0. So that's what we need to execute work on the GPU. We need a queue and we need a fence in order to do it. Now the queue is just needed to do the work on the GPU, and the fence is only required to synchronize that if the work is finished on the GPU, we also know it on the CPU side. And with these three things and the GPU, we will be able to execute work. This is the only thing that we will need here. I do not need to write any complicated graphics code here with like abstractions of the queue and things like that. I want to have it all just very, very simply here in my main graphics class. Now, what we need to do is, of course, we need to create it now. So I need to call on my GPU and tell it to create a command queue in here by calling the create command queue function. So this is requiring a descriptor, and it needs to go to my direct queue. There it is, to my direct queues and IID PPV arcs, which is just a helper macro actually. I have not explained that here, but if you're interested in just DirectX 12, you should watch my DirectX 12 video series. D3D12 command queue desk. Okay, D3D12 command queue desk. Command queue. I really hate having non-explanatory names, but let's call this just queue description, queue desk like that. And then what we need to do is we need to, of course, take a look what's inside. I do know what's inside, but for you, if you are new to all of that, just take a look what's inside and just try with the documentations to go step by step forward to fill this in. Now what list type do we want to have? We want to have a direct list which can basically do everything. D3D12 command Q priority is going to be high because we make a game. We do not have any flags and we put an open mask of 0 because we don't care about multi-adapter usage. We're just going to have one GPU in here so we can put it to 0 and it's been figured out by the system. Okay, so that's as easy as we can create a command queue. Now we just need to create a fence. MGPU device, create fence. So how can we create a fence? We need an initial value. We directly take the one that we have inside. IID PPV args to my direct queue fence, and that's it. We have a fence and we have a queue. What is your problem? What? What's now going on? Ah, we have to have some flags. Okay, we need some flags in here. D3D12 fence flags. Fence flag none. That's what we have. We're gonna have a fence with no flags. And that's everything. Now we have a fence and we have a queue. And with these informations we can go further and actually implement the details that we have on the window, but I don't want to do that. I want to maybe now start and write some auxiliary functions. I want to have an auxiliary function called void flush queue with a parameter size t of flush count equals to 1. This is just going to be a simple function that allows us to flush our queue from internally and externally of that class. So this one flushes the GPU queue, and then we have a flush count, number of flushes to occur. Basically what a flush is basically we try to signal our fence and then we wait. This is how we need to do flushing. Flushing is important if we work with DXGI, because DXGI and the swap chain, they basically inject work onto our queue, and in order to synchronize this work with our application, we just need to flush it a certain number of times. Or flushing basically means signaling. Don't ask me why we need that, but we need it. That's really important that we need to flush it, and we need to actually flush it as many times as we have frames in the queue. Additionally, what I want to do is I want to have a function, wait for fence, with a uint64 fence value. So I want to be able to wait for our fence. Waits for the fence for a given value. And I want to put this one actually to -1. Value to wait for when -1 waits for the current max fence value. So this is how it works. Wait for fence. So this is basically what we need to do. These two functions are really important. We're gonna see how they work in a second. Now, first of all, flushing the queue is quite simple. For size t I equals 0, I smaller flush count I++, simple like that. And then what I basically do is I wait for fence. I wait for my fence multiple times. And before I do that, I actually need to signal the fence. So direct queue fence, it's going to get a signal event. No. Direct queue will get a signal event to my fence with direct fence value incremented. That's really important. We increment the value, and this value is then being fed to the signaling, and this basically means that as soon as the direct queue has finished the work and reaches in the queue the signal command, so basically if you're calling functions on the queue, you're placing commands on the queue, you can place command lists or the signal events on the queue, and the queue will synchronize with the GPU, and as soon as it goes to the signal, it will basically see the fence object, and it will put this value on the fence object, and this is the incremented one of the old value that we store on the CPU side. And then we wait for the fence, we wait for the active value for the fence. So if fence value equals -1, then I basically will say fence value is that value. That is just a way of adjusting this parameter. And then the first thing that I need to check is that directQ fence, and I'm actually going to the fence and I'm trying to get the completed value. And if this is smaller than my fence value, I need to actually wait for it. Waiting for the fence is done with an event. So handle directQ fence event. So that is the event that I can use for that. I just want to use an event here to do not put too much load on my GPU by having an event in here. It's basically telling the operating system, hey, stall the application until the event is triggered. And this is a nice way of synchronizing and waiting without an infinite loop that just runs and needs some idling from our side. Okay, so directQ fence value, fence event equals create event. Create event is quite simple. Null pointer, false, false, null pointer. This is the most simple event that you can get. Just the simplest end. I think there's actually a W version of it. Okay, let's do it like that. Okay, now of course these things need to be all a bit released. I don't want to forget that. The queue needs to be released like that. It's important that you use the dot function, by the way, and not the arrow function, otherwise you're gonna have the whole world burning. Yeah, so these are the released. Then destroy event, I'm not sure. Close event is, I think, not a thing, so close handle should be used on here, and then we can release the fence, the queue, and the device. That's good. But actually what I want to do is I want to flush the queue multiple times before I'm going into my destructor. That's just something that you should be doing every time before you destroy. So flush queue for 2 times because we're going to use double buffering. We could actually make this a constant, maybe. Public const expression, let's put it as an int, buffer count equals 2. Yeah, let's make this a static const int buffer count, or maybe then we can use it like that, so it makes a bit more sense. Okay, so that's more or less it here. So this one is done, but we need to continue on in here. Okay, so if we are not completed, we need to make sure that our event is signaled. So for that, I'm basically telling my fence to set the event on completion. The event will be set when the fence value is reached, and the event is the event that I have here. And if this is, so if this succeeds, then I can wait for the event. If this does not succeed, I need to fall back into an operation. So there's going to be a fallback in here, directQ fence get completed value smaller than the fence value, sleep 100, or let's maybe say sleep 1 millisecond. Just a very fallback wait. And if this succeeded, then yeah, what we basically want to do is wait for a single object. So I want to wait for my directQ fence event for like 30 seconds. If it does not work, so if this is wait object 0, which means that it was successfully, then we are done. We can return out of that, and otherwise I also want to go into my fallback wait. If there is any stall on the GPU, this should not be a problem, but I think this is kind of redundant. I think we could just wait for the single object, but I like to, at least if I put in a timeout, which you always should for these functions, yeah, I just want to make this a bit more robust by doing it like that. If it's necessary, I don't know. Now that's actually everything that we need. And for flushing, it's quite simple. We're signaling it and we wait for it. Okay, quite simple. These functions are exposed so that they actually can be used outside of it. And now this is all of the auxiliaries that I really need now. Every other like auxiliary code, I maybe want to break it up here and then actually implement the swap chain in the next video, but we at least have all of the code now ready to start implementing the swap chain, the actual swap chain. But still, you can see our window is still working. It consumes quite a lot of more memory. Actually, that's quite high, but I think this is because of all the bloatware we loaded in our application. It's not really bloatware, but you can see like a lot of external code, like a Windows code, DirectX code, driver code, DXGI code. There's a lot of code going on that, of course, all litter in our memory. That's just how it is. You need it. Like, the graphics application has all the time quite a lot of overhead already going on. But yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.